Hello guys, welcome to this chemistry lesson, and in this lesson I'll be answering some chemistry questions, and I'm sure you can see these questions are coming from the topic stoichiometry, and this is a very easy question. I'm sure most of you at some point you might have come across such kind of questions. So I would like to review how you can tackle such questions when you find such in maybe assessments like exams. It could be tests. This is very easy, and kindly see how I'm going to arrive at to the answers. The first question is saying construct a balanced chemical equation for the reaction, include state symbols. That's the first question. So this is a very easy question. When you look at the question, we are given 2.0 grams of pure magnesium ribbon reacted with exactly 100 cubic centimeters of 2 mole per cubic decimeter hydrochloric acid. Construct a balanced chemical equation for the reaction. Include state symbols. This is easy. So the first part, we are going to first of all write the equation. Magnesium, this is how you write the symbol for magnesium. It is reacting with hydrochloric acid. This is the formula for hydrochloric acid, and the product for such a reaction is magnesium chloride, which is a salt, plus hydrogen gas. This is easy, guys, because we understand that acids behave in a certain way when they come into contact with metals. And I'm sure regardless of the acid, we can even use another acid here, maybe nitric acid, but as long as it is reacting with a metal, the product will always be a salt and hydrogen gas. So that is one of the chemical properties of all acids. So this is a very important principle to remember. It may assist you in coming up with correct equations for chemical reactions that are involving acids. So the next part of this particular question, we are told to balance the equation. So when balancing an equation, it's very, very easy. You need to ensure that you identify what you're given. We have reactants, we also have products. The number of atoms of each element on the side of products as well as on the side of reactants should be equal. So in this case, we have magnesium atom, which is 1, and here we have magnesium atom, which is 1. So these atoms are equal, so it's fine. You don't even do anything to these atoms. But when you look at the next one, we have hydrogen here. Hydrochloric acid has hydrogen here, which is 1. And on the other side, we have 2 atoms of hydrogen. So this is not balanced. So what we need to do is we are going to add a stoichiometric coefficient in front of hydrochloric acid so that it can actually affect the number of hydrogen atoms. And here we are going to have 2 atoms, and here we have 2 atoms. When we add this number in front of hydrochloric acid, it also affects the number of atoms of chlorine. So we are having 2 atoms of chlorine, and already here you've seen that we already have 2 atoms of chlorine because of this subscript. This subscript is coming from the formula for magnesium chloride. So as you can see, the equation is balanced. But we are also taught to include state symbols, and we already know that state symbols are just representing the state in which a particular substance is in. It could be solid, it could be aqueous, it could be liquid or a gas. And we can see magnesium ribbon, most metals are in solid state, so we put a symbol S. Then acids, mostly they are aqueous, and salts, aqueous. This is an aqueous salt. Some of the salts are in solid state. When we look at solubility rules, I'm sure you'll be able to tell which ones can form, which ones are soluble, which ones are insoluble. But magnesium chloride is a soluble salt, so it is in aqueous state. And hydrogen is a gas, so we put the symbol G to represent that it is a gas. So that is how you balance the equation. That's how you handle the first part of the question. The second part of the question is asking us to find, they are saying determine the limiting reagent. Now, limiting reagent, we need to know what a limiting reagent is. What is a limiting reagent? I think that is something that is important when addressing this kind of a question. You need to know what a limiting reagent is. What is a limiting reagent? It's very easy. A limiting reagent, or sometimes they may refer to it as a limiting reactant. A limiting reactant is a reactant in a chemical reaction that produces a less number of moles of product. That's what it is. I repeat, a limiting reactant in a chemical reaction is that reactant that produces a less number of moles of product. Sometimes we can refer to it as a reactant that depletes first in a chemical reaction. So whenever you're given a question that has to do with limiting reactants, first of all, you need to find the number of moles of the two reactants. I'll start with magnesium. So I'll write it here, magnesium. We want to find the number of moles of magnesium. That's what we want to find, number of moles of magnesium. So what do we do? In order to find the number of moles of magnesium, we are going to use the formula. Number of moles is equals to mass over molar mass. The reason why I've picked this formula is because from the question I can see that we have been given 2 grams of magnesium ribbon, and this is a mass. We have been given a mass, and we can find the relative molecular mass. So since we have this information, that's why I've picked this equation. So number of moles is equals to, we substitute, we have 2 there, which is 2.0, it's the same thing. And then magnesium, the molar mass for magnesium is 24. How are we finding 24? Because we can see we have 1 atom of magnesium here. So we are going to say 1 multiplied by the relative atomic mass, which is 24. So we are going to divide number of moles 2 divided by 24, which is mass divided by the relative molecular mass. So when we compute that on a calculator, what we are getting is the number of moles for magnesium is 0.083, okay, moles, okay, of magnesium. That is the number of moles that we are finding, okay. Then we now also solve the number of moles for hydrochloric acid. Now in this case, hydrochloric acid, the number of moles for hydrochloric acid, HCl, we use the same formula. Number of moles is equals to, but in this case, let's check the question. We have been given, from the question we have been given magnesium ribbon reacted with exactly 100 cubic centimeters of 2 mole per cubic decimeter hydrochloric acid. So we are not going to use this formula. In this case, since we have been given the volume of the acid, we have also been given the concentration. So we are going to use this formula. Concentration is equals to number of moles over volume. That's the one that we are using. But in this case, we are solving for number of moles. So we make the subject of the formula by saying over 1 to be number of moles is equals to concentration multiplied by volume. Then we say number of moles is equals to, the concentration given is 2 mole per cubic decimeter multiplied by the volume. The volume given is 100 cubic centimeters. But when you're dealing with concentrations of solutions, you need to ensure that the volume is in cubic decimeters. So we are going to convert this one in cubic decimeters. So we know that 1 cubic decimeter is just the same as 1,000 cubic centimeters. So basically what this means is that we are going to say, if we are given 100 cubic centimeters, what is the volume in cubic decimeters? We don't know, so we say x. So we know that x will be, is just the same as 100 cubic centimeters divided by 1,000. And when we divide that, we are going to get a 0.1 cubic decimeter. That is the volume. So we get this and then we put it here, 0.1. And then when we compute this, that is 2, when we compute this on a calculator, 2 multiplied by 0.1, we are getting a 0.2. So number of moles is 0.2 moles. That is for HCl, which is hydrochloric acid. So that is the number of moles. Now that you have found the number of moles of the two reactants, the next thing that you need to do is you need to compare the number of moles with one of these products. Like I said, a reactant that produces a less number of moles of products is what we call a limiting reactant. So we are going to make a relationship here between the reactant, one of the reactants, and one of the products. So we are going to pick magnesium chloride. So we say magnesium, we'll start with the first reactant. We make a relationship. Magnesium with magnesium chloride. We pick it exactly the way it is in the chemical equation. So like you can see, the mole ratio between magnesium and magnesium chloride is 1:1, according to the balanced chemical equation. So meaning, what this means is that the number of moles of magnesium is equal to the number of moles of magnesium chloride. That's what this means, since they are in a 1:1 ratio, mole ratio. So which means that magnesium chloride produces 0.083 moles of the product. So this means that when we say 0.083, then here x, the value of x is going to be 0.0883 moles of what? Magnesium chloride. That is the number of moles produced when we make a relationship between the reactant and the product. So this is only for magnesium. Let us now see for hydrochloric acid. We pick it the way it is in the chemical equation. We make a relationship. So there's 2HCl. We make a relationship with magnesium chloride. We are picking the same reactant. I mean the same product. So between the two, we can see that hydrochloric acid is in a 2:1 mole ratio. The mole ratio between hydrochloric acid and magnesium chloride is 2:1. So when we make such kind of a relationship, we know that since we have 0.2 moles of hydrochloric acid, how many moles of magnesium chloride can we have from such kind of moles? Then we cross multiply. So it will be 0.2 is equals to 2x. Then we divide both sides by x, this and this. So therefore, we are going to have x is equal to 0.2 divided by 2. We are going to get 0.1. So in short, we are getting 0.1 moles of magnesium chloride. So now, when you compare these two calculated moles of product, which one is less, which one is greater? You can see that magnesium produces a less number of moles of product because this is 0.083 and then this is 0.1. So this is greater than this. So in conclusion, you can say, therefore, magnesium Mg is the limiting reactant. Therefore, Mg is the limiting reactant because it produces a less number of moles, of product. And you can see from these calculations. So when you're given such a question, you don't just say this one is limiting. You have to show by calculating, just like I've done it. I hope you have learned one or two things here. Thank you so much for remaining attentive. See you next time in the next video.